Alright, hello, my name's Dave and this is just a short video about this 1/8 buggy project that I've been working on. Okay, so here's the buggy. Basically it's just a quick video to show people what the project has been all about. Some people have been following the project on the web, looking to see more pictures and whatever video. See what's going on in this car. So what it is, it's a 1/8 scale car. So by that I mean it's built to exactly the same wheelbase and track as a standard 1/8 buggy that you can buy. So it uses standard wheels and tyres. Basically it's been made so that all the expendable items on the car you can just buy off the shelf, because I've learnt in the past doing project cars that if everything's completely homemade, you tend to not want to run it so much because you know there's so much effort involved in getting it running again. So what you've got is a rear engine layout. Just have a quick look here. At the moment I've got a Kalari 32 engine mounted up there. It's pretty unconventional. Usually you'd obviously have a mid-mounted engine and central transmission shaft with 3 diffs. This setup's got obviously a rear engine with only a single diff. That's just a standard diff I've used at the moment out of a Kyosho car. See that in there. That's not great. Basically the rear suspension, everything like that, and the rear gearbox section is the most complex area of the whole car. It's pretty busy in there. There's not much space. There isn't a great deal of space to get everything in. I've got a twin disc transmission brake on that lay shaft there. I'm sure the lighting's really good actually. So you can see, hopefully, in there you've got this lay shaft here with a standard hardened steel spur gear on there, standard clutch bell. The gearing is such that it's pretty much the same sort of ratio as you'd run on a standard 8th car. This secondary clutch bell is actually just a way of getting that pinion gear on the shaft. There's a machined aluminium hub inside there, all heavily licensed. It's not the best solution because obviously there's a lot of extra rotating mass, but it's the easiest way of doing it in this case. I'll probably change that in the future. And then on the end we've got the disc brake here. Now this is quite interesting. This is quite a fun part to build. Basically I've got twin materials. Inboard disc is aluminium, grooved aluminium. Outboard is zirconia monolithic ceramic disc. Now I machined that out of pre-sintered zirconia blank, and then sintered it in a furnace at 1470 degrees. You have to accommodate for the shrinkage and everything. But in doing that you get a pretty unique ceramic disc that you don't really see that in RC at the moment. I don't know how well it's going to work, but it will be very, very wear resistant. But who knows what the braking performance will be like. But having 2 disc materials is a great way of minimising the chance of losing braking power in different conditions. So if they get wet, one of them will be better than the other. If they get extra hot, one of them will work better than the other. Talking of heat, you've got air-cooled caliper. It's got quite a few big heatsink fins on there, and then the actual actuation arm, if I can just show that, it actually goes through the rear shock tower and actuates the brake like that. So there's a push rod here, and you can see the servos mounted. It's a bit messy. Servos mounted in the centre of the chassis on a carbon fibre tray. That receiver is actually going underneath this cover here, so all of the electronics, everything is going to be completely encased in a solid structure, so it should be pretty damn durable. The chassis plate itself is solid polycarbonate. That's just as a dirt protection and water protection. It doesn't actually serve any structural purpose at all. All the force and stress is taken by the solid chassis rails here. They are 60-61 these chassis rails. Most of the material's actually been removed from them, and I've got press-fit carbon fibre inserts, which give you a really, really light and very, very strong and stiff chassis. I use that same technique all over the car actually, and on lots of these elements here, front upper wishbones there as well, top links I should say. Got them on the rear. My favourite area of the car really is the this rear section, where I've milled out all this material here. I've got extra mounting holes on the back of the chassis. That's going to be used for the rear engine cage, which I haven't built yet. That's going to be done with a nylon rod, and that's going to form a complete structure around the engine. Still open because you obviously need a lot of cooling on these engines, but it should be good. There's a lot more of the engine exposed to airflow than there is on a standard car, so you're cooling the crankcase and everything else, which normally you don't get. Other features that you don't normally see on cars, this steering system is done with a high tension steel wire, steel cable. It's used in closed loop systems for rudders and model planes. Same idea really. That runs through a linear rack, so you can see that move like that. You actually get, as a result, because it's completely linear rather than running on rotating bell cranks, it's much easier to predict the sort of Ackerman angles you're going to get, and you also get a hell of a lot more travel for a given servo motion from this system. I've got a servo saver on there. So that's pretty pleasing, that, because I thought I was going to have to build a hydraulic system to run that steering, which wouldn't have been very easy. But this seems to work really well. And it's very low profile. If you look down here, it doesn't stick up very much. So it means you can get a much lower body on the front. And then I've got my fuel tank, which is just simply bolted on. Nothing particularly special. The other thing to note that isn't done yet is the exhaust system. What's going to happen there, I'm going to have a pipe across the back of the engine on top, hopefully not obstructing the cooling too much, but who knows. And then a custom made exhaust manifold, which I'm going to weld up out of aluminium. I haven't done that yet. And then there's the body shell, which is very simple. Just goes on like that. I haven't done the retention clips yet. But it looks much more realistic than a standard buggy, as you can see. It's much more like a real desert car, which is the sort of thing I was looking for really. Okay, and then just got one more thing to do on this car apart from the exhaust mounting. You'll notice the rear of the car sits too low. There isn't enough, there's way too much down, way too much sag in the suspension. So I've got a lot of travel there, but what I need is it to sit a bit higher than that. The reason is because the standard 1/8 car springs obviously aren't designed to handle a car with all the weight hanging off the back. So you can't get springs that are stiff enough. So I could use engineering springs or custom wound springs or anything like that. But what I'm going to do is I'm going to have a second shock, an auxiliary shock bolted on the back of this one. That'll be another custom made job. And then that's going to have a small spring inside it, but no damping. All the damping will be handled by this. The auxiliary shock will be independently preloadable, and you obviously be able to change the springs out. The springs will be internal in it, so you will be able to adjust the springing of the car without touching the main shock. And I think that will make it a lot more adjustable and just another nice feature. It will look like an external reservoir that you get on the real cars. But you don't really need them on these cars. Oil doesn't get hot enough. So yeah, there's a quick overview of the car. Front suspension, haven't said much about. It's got 25 degrees of kick up on the front. That's basically just exactly the same as you'd get on a two-wheel drive electric car. Obviously this car being two-wheel drive, much of the handling is going to be similar to what you'd see on a 10th scale electric two-wheel drive buggy. The weight distribution is also very similar. And then you've got this roll cage, which is woven carbon fibre and aluminium. So the all-up weight of the car is less than a four-wheel drive. Obviously with a 32 in the back, it's going to be quite easy to wheelie, I think. But it should be a hell of a lot of fun to drive, and I'm really looking forward to that. Okay.